Hi. In this session we will learn about file handling and templates. Here is the list of what we will be covering in this chapter. Files in C++. A computer file is the permanent resource for storing information as data units. Once a file is created, it can be accessed by independent programs for processing and reports generation. Input-output operations using files. C++ provides the following classes to perform input and output of data to or from the files. Of stream. It is the stream class to write onto files, the output file. If stream. It is the stream class to read from files, the input file. Fstream. It is the stream class to read and write from or to files, the generic file. These classes are derived directly or indirectly from the iStream and OStream classes. We have already used objects of these classes. Cin is an object of class iStream, and cout is an object of class OStream. Therefore, we have already been using classes that are related to file streams. We can use file streams similar to how we use cin and cout. The difference is that files store data permanently, while cin and cout work with variables that are temporary memory locations. Let's now have a look at our first C++ program in file handling. Program 48. Write a line of text content into the file 1.txt and save it in a specific directory. This is the program code. Remember that we are going to write contents into a text file, and so we will be using the object of an ofstream class. Program control shifts to line 6, where we have created an object named myFile from the standard output stream class ofstream. It is this object, myFile, which we use to execute several of the functions related to file writing features. Control then shifts to line 7 of the program code. It commands the system to use the myFile object and open a writable file or output file named 1.txt in the E drive. So, in the local disk drive labeled E, an empty file named 1.txt is created. It would look like this. In the program code, the control next shifts to line 8. It's an insertion operation similar to the cout command. The difference is that in this case, the contents within double quotes are written to the file named 1.txt that's opened as an output stream object. Note the file 1.txt. The contents up to new line character \n are written to the file on first line. Then the next line is printed, again followed by a new line character. In the program code, the control shifts to next line. The content given here is written to the output file. Once again in the program code, control shifts to next line. The content given is written on the same line. In program code, next line is executed, and the output file or 1.txt is closed. On line 12, the cout message is asked to be printed, and the program ends. You can now go to the local disk drive labeled E, click the 1.txt file, and check for yourself if the contents have been written into the file. So here, we learned how to write text contents into a file using an output stream object. Next, let's dig deeper into the file open function that we just use on line 7 of this program. Opening a file. We can open a file with the stream object using open function, and the syntax is open, filename, mode. This is an example. myFile.open, example.txt, where myFile is the output file stream object, which we just learned in the last program. In the syntax, filename is a null-terminated character sequence of type const char star, the same type that string literals have. It represents name of the file to be opened. The mode is an optional parameter with a combination of file mode flags, as shown in the given chart. You can have a good look at it. Two or more of these flags can be combined together using the bitwise operator, the pipe character or. Suppose we want to open the file, example.bin, in the binary mode to add data, we write these statements. First we declare the output file stream object. I name it myFile. Using myFile object, we then open the file named, example.bin, as an output file, where contents will always be appended at the end of existing contents, and the file will be saved in binary format. If the file mode is not specified along with an open function, the corresponding default mode is set automatically for the classes offstream, ifstream, and fstream. Refer this chart for default modes of the 3 FileStream classes. For offstream, it's iOS out. For ifstream, it's iOS in, and for fstream, it can be both iOS out and iOS in. When no file open mode is specified for the ifstream classes, iOS in is assumed by default, and for offstream classes, iOS out is assumed. If the function is called with any file mode parameter, the default mode is overridden or not considered. File streams that are opened in the binary mode perform input or output operations, independent of any format considerations. Example: to open a file in binary mode is given here. To check if a file stream has successfully opened a file, you can call the fail function with no arguments. This function returns Boolean value true if the file did not open because the file doesn't exist. It returns false if the file exists. If the file does not exist, we come out of the program using exit 0 command. Use header file stdlib when using exit function in some compilers. The general format for fail function is like this. If myFile.fail function, exit 0. Else, proceed with the program to read or write into the file. Note: exit 0 indicates a successful program termination, and exit 1 indicates unsuccessful program termination. Closing a file. When we have finished with input or output operations on a file, we will close it so that its resources become available again for other operations. The close function is used to close an open file. This member function takes no parameters and flushes the associated buffers to close the file. Example: myFile.close function. Once this member function is called, the stream object can be used to open another file, and the file is available again to be opened by other processes. Text files. In text-based file streams, we do not include the iOS binary flag in their opening mode. These files are designed to store text, and thus all values that we input or output from, or to these files, can suffer some formatting transformations, which do not necessarily correspond to their literal binary value. Data output operations on text files are performed similar to how the cout statements worked. File input functions. File input functions are used to read or fetch data from a file. Common input functions include: number 1. Reading of character data. Get function is used to read a character from the file. Data input can be from a file into a variable, or from one file to another file. Syntax for usage is FileObjectName.getVariable. Number 2. End of file. EOF function checks if end of file has reached. This function returns Boolean value true when program control reaches the end of a file. Syntax for usage is EOF function. Number 3. Reading of numeric data. The greater than operator is used to read numeric data from the file. Syntax for usage is FileObjectName, variable. We will now write a program to read any .txt file and display it. Here is the C++ program, and note that since it's the program to read a file, we will be using input FileStream object. The program control moves to line 6, where we declare 2 character variables, ch, and myFileName with 50 as the character limit. On line 7 we have instructed to prompt for the file name. I enter 1.txt, which we had just created in our last program. The file name that I typed in gets stored in the variable myFileName. Program control then shifts to line 8, where we create the input FileStream object, named myFile, and using this object, we open the file that's stored in variable myFileName. Then on line 9, it's checked if the myFile object has succeeded in opening the specified file. Note that the current folder we are in is the F drive. You can cross-check it at the top left corner here. Remember that we had saved the 1.txt file in local disk E, and the system will search for 1.txt in the current folder, that is in F drive. So the system will generate an error as the file couldn't be found and opened. Hence the control enters the if block and prints, unable to open file. It will then exit this program by the exit 0 command. Let's check another scenario. On line 7, when the program control prompts to enter file name which is to be read, I enter file name with the path /1.txt. It's stored in the variable myFileName. On line 8 of program code, we create the input file stream object myFile from the class ifStream, and open the file 1.txt from eDrive. Line 9 checks if opening the file failed or not. This time, the file open operation is a success. So control doesn't enter the if block and jumps to line 14. File open success statement is printed onto the output screen. Here is the 1.txt file for our reference. Note that when a file is opened, by default, an internal pointer points to the first location in the file. Control shifts to the next line, and it says, get the character where the file's internal pointer is pointing to and save it in ch. It's pointing to the first character m. So m is stored in the variable named ch. Program control then shifts to line 16, the while loop. It checks if we have reached the end of file. No. It's just the first character in the file. Hence, the control enters this while loop, and counts, or prints, the character ch on output screen. Program control then shifts to line 19. It says to get the character. Note that after the character m, as read by the previous get function, internal file pointer auto shifts to the next position. So now, the next character y is copied to the variable ch, and control shifts to top of while loop. It's checked if end of file has reached. Once again it's a no. Line 18 is executed. On output screen, the character y is printed. The loop continues. Entire contents as in the file 1.txt are printed onto the output screen. Next line. Then the next line. And finally the program terminates. So this is how the characters from a text file are read by the input file stream. Let's next look into the file output functions. File output functions are used to write data into a file. Common output functions are, number 1, writing of character data. Put function is used to write a character into the file. Syntax for usage is, FileObjectName.put, variable. Number 2, writing of numeric data. The less than operator is used to write numeric data into the file. Syntax for usage is, FileObjectName, variable. Let's write another program. Program 50. Create a file named markList. Accept the first name and 2 marks of a student. Write them into a file. Then read it from the file, and print details with total marks. Since we are writing data into a file, we will use the output file stream object. On line 6 of the program, we create an object named outFile of the output file stream, offstream, and open a new file named marklist.txt. On line 7, we declare character variables nameOut and nameIn, of maximum size 20. On line 8, we declare integer variables, I, tot, and arrays, mout, and min. On line 9, the user is prompted to enter a name. I type Paul. It's stored in the field nameOut. On line 10, the output file stream object, outFile, is used to write the content within nameOut field into the file we opened. So Paul is written into the file, marklist.txt. The program then executes for loop to get 2 marks. First I is set to 0. Is I less than 2? Yes. Line 13 prompts for marks. I enter 89. It's stored in the array, mout of I, or mout of 0. On the next line of code, the field tot, which is already set with a value of 0, is added with the value we stored in mout of 0. Tot now becomes 0 plus 89, and that is 89. On the next line in program code, we use the outFile object to write a space into the file, marklist.txt, and then write the marks stored in mout of 0. Program control shift the top of the loop. I is increased by 1 and becomes 1. Loop condition is checked. I is less than 2, and so once again the marks is asked. I enter 99. It's stored in mout of 1. tot, for total marks, is updated with the second marks we just received. Tot becomes 89 plus 99, that is 188. OutFile object writes the value in m out of 1 to marklist.txt file. Control shifts to for loop header. I becomes 2 and for loop stops. We received the name and 2 marks of a person as required, and have written them into a text file. We have also calculated the total marks obtained. On line 18 we close the file marklist.txt. We next have to print onto output screen the contents we had written into the file marklist.txt. So on line 19, we open the file marklist.txt by creating the input file stream object in file. You can use any name for the object. I have used in file. So the file opens, this time in read mode. On line 20, we print the title marklist. On next line, we print the subheadings. Program control shifts to line 22 where it checks if it's end of file. No, it's not. So control enters the while loop. On line 24, it says using the object in file, get first block of data into the memory variable name in, second data block to array min of 0, and third data block to array min of 1. So Paul is copied to name in, 89 is copied to array min of 0, 99 is copied to array min of 1. Lines 25, 26, 27, and 28 prints the values onto output screen. Since now, the file pointer is at end of file, control exits while loop and the input file is closed. So in this program, we learned to write character and numeric data into a file, and then retrieved contents from the very same file. We will next learn about reading and writing a set of characters.